Right now, one country is simultaneously finishing the most expensive project ever built, the tallest dam ever built, the longest sea crossing ever built, and the fastest train ever tested, all in the same decade. You heard that right. To picture that pace, it is as if America were building the Hoover Dam, the Golden Gate Bridge, the interstate system, and the Apollo program in the same 10 years. But here is the twist. Nobody outside the engineering community is willing to say out loud. China is not even bragging about most of it. Stick with me to the end, and you will see exactly why engineers around the world are quietly admitting China is now operating in a different era. And if that sounds like a story worth following, the like and subscribe buttons help more than you would think. We start with the most expensive single project in human history. The $170 billion river. Picture a river so violent, it has carved one of the deepest canyons on Earth. A canyon nearly twice as deep as the Grand Canyon, slicing through the Himalayan mountains where the air is so thin, a healthy adult gets dizzy walking up a single flight of stairs. That river is called the Yarlung Tsangpo. It tumbles off the Tibetan Plateau and drops nearly 9,000 feet over a short stretch of mountain, roughly the height of 7 Empire State Buildings stacked on top of each other. All that falling water carries an unbelievable amount of raw energy, and China just decided to build a dam there. Not just any dam. The Yarlung Tsangpo Mega Dam will cost $170 billion. To anchor that number, that is more than the entire annual military budget of Russia spent on a single piece of infrastructure. It is officially the most expensive construction project in human history. And once it switches on, it will generate 300 terawatt-hours of electricity every year. 300 terawatt-hours is more power than every single home, factory, hospital, and office in the entire United Kingdom uses in a year. From one dam, in one valley. Now, here is the part most people never think about. The Three Gorges Dam in central China was already the largest dam on Earth by output. The Yarlung Tsangpo project produces almost 3.5 times more electricity than that. So the country that already owned the biggest hydropower facility ever built decided the right move was to build something 3.5 times bigger on the side of the Himalayas, in some of the most punishing terrain a human being can stand on. Think of building this dam like trying to assemble a watch on the summit of Mount Everest. The pieces are delicate, the work is exacting, and every breath you take pulls in roughly half the oxygen your body is used to. Construction crews working on the Yarlung Tsangpo Dam are operating at altitudes where helicopter blades lose lift, where diesel engines lose power, where cement cures differently because the air pressure is wrong. Workers rotate in shifts because nobody can stay up there for long without their body breaking down. The Himalayas were not designed to be a work site. China made them one anyway. Here is the detail that makes engineers around the world quietly shake their heads. Western construction firms looked at this exact valley for decades. Surveyors visited. Reports were written. The same conclusion came back every time. Too remote, too high, too geologically active, too expensive. The project that the rest of the engineering community filed away under impossible is the one China just decided to start building, and it is on track to switch on this decade. But generating more electricity than an entire G7 nation is only the warm-up, because the next breakthrough involves a structure so tall, so thin, and so impossibly placed that it makes a skyscraper look conservative. The two bridges that should not exist. Walk to the edge of the tallest building in your city. Look straight down. Feel that pull in your stomach. Now imagine that the ground beneath you is not concrete and asphalt. It is a canyon. A canyon that drops more than 2,000 feet straight down, taller than the Empire State Building from the ground floor to the spire. The river at the bottom is the size of a thin silver thread from up there. And the only way across is a single ribbon of road suspended in open sky. That is, the Huajang Canyon Bridge in Guizhou Province. When it opens, it will be the tallest bridge ever built. Think of building this bridge like threading a needle from the roof of one skyscraper to the roof of another, except the wind is constantly shifting, and one mistake drops the needle 2,000 feet. The deck stretches almost a mile across the canyon. Every cable, every steel section, every concrete pour had to land in exactly the right place above a void. Conventional surveying tools could not see across that distance accurately enough. So Chinese engineers used drones, equipped with high-precision positioning systems, to guide every component into place from the air. They built a bridge in 3 years using flying robots as their reference points. To picture what that bridge does for the people living there, a road trip that used to take 4 hours through winding mountain switchbacks now takes 4 minutes. Building a record-breaking bridge over land is one challenge. Building a bridge across open ocean, in typhoon country, is another universe of difficulty. And China decided to do both in the same decade. Look at a map of the Pearl River Delta in southern China. 3 cities sit around a wide bay: Hong Kong, Zhuhai, and Macau. For most of the 20th century, traveling between them meant ferries or a long detour by land. The Chinese answer was to build a bridge straight across the bay. 35 miles of road and tunnel through open ocean. It is the longest sea crossing ever built. To anchor that number, it is roughly the same distance as crossing the entire English Channel from Dover to Calais, then doing the trip a second time. Here is the problem only a handful of marine engineers ever discuss out loud. You cannot just lay a bridge across 35 miles of salt water. Ships have to pass underneath. Sediment shifts the seabed. Earthquakes shake the foundations. Typhoons rip across the South China Sea every summer. So Chinese engineers built 2 artificial islands from scratch in open ocean, dropped them into the bay as anchor points, then ran a tunnel between them under the shipping lanes. The bridge itself is engineered to survive a Category 16 typhoon, a magnitude 8 earthquake, and a direct strike from a 300,000-ton vessel. To picture that ship size, that is a fully loaded supertanker, bow first into the deck. The design life is 120 years. But pulling a bridge through the sky and building artificial islands in open ocean is only the start, because the next breakthrough required drilling a railway straight through the most geologically violent terrain on the planet. Through 14 earthquakes and into the sky. Imagine drilling a hole through solid rock. Not a small hole. A tunnel wide enough to drive a passenger train through, miles long, straight through the spine of a mountain. Now imagine doing it at an altitude where the air has so little oxygen that your lungs cannot keep up with a brisk walk. Now imagine that the rock itself is so hot it burns through standard drill bits. That is the Sichuan-Tibet Railway, and the people building it are doing something the global engineering community said could not be done for the better part of a century. The route stretches between the city of Chengdu and Lhasa, the capital of Tibet. 90% of it runs above 10,000 feet. For context, that is higher than the summit of Mount Olympus in Greece, sustained for hundreds of miles of railway track. Most of the route is not even on the surface. It cuts through a single section that requires 47 tunnels and 121 bridges, threading through the most violent geology on the continent. The railway crosses 14 active fault lines along its length. 14 separate places where the Earth itself is splitting apart at a rate engineers can measure year by year. Here is the part the tunneling industry quietly hopes you never hear about. When you drill deep enough into a mountain, the rock around you starts releasing heat. On the Sichuan-Tibet line, drill temperatures inside the tunnel bores have reached 192 degrees Fahrenheit. That is hotter than a fresh cup of coffee, pressed against the workers' bodies for an entire shift. Add in the thin mountain air, and you have an environment that human beings physically cannot tolerate without rotating crews, oxygen support, and cooled water lines pumped in from outside. Western firms studied this corridor for decades. They walked away every time. China simply kept building. Roughly 200 miles south of that railway, in the same earthquake-prone province, sits another project that should not work on paper. The Shuangjiangkou Dam. At 1,033 feet tall, taller than the Eiffel Tower, from the ground to the tip of its antenna, it is now the tallest dam ever built by human hands. And it sits in some of the most seismically active terrain on Earth. Think of the dam like a giant pile of carefully stacked stones, except every stone is engineered to lock into the ones around it and absorb shaking instead of resisting it. That is the principle behind a rock-filled dam. When the ground trembles, and it will, because this is Sichuan, a concrete dam can crack. A rock-fill design flexes, shifts, and stays intact. The Shuangjiangkou now generates 3 gigawatts of clean electricity from a location every conventional risk assessment said was unsuitable for a structure of this size. 3 gigawatts is roughly the output of 3 full-scale nuclear reactors, pulled out of a place the engineering community said could not safely host even one. But drilling through the planet's most violent geology is still working with the natural world. The next breakthrough is a building so large and so automated it makes a city's entire transportation network feel obsolete. The airport that replaced the passport. Picture the last time you flew through a busy international airport. The long walk to the gate, the maze of corridors, the terminals that branch off like spokes on a wheel, each one a separate small city. Most major airports grew that way. A terminal added here, a concourse stitched on there, decade after decade, until the whole thing became a sprawling patchwork held together by buses and trains. Now imagine an airport built the opposite way. One enormous single building, one unified roof, every gate within a 6-minute walk of the central hub. That is Beijing Daxing International Airport. Think of the floor plan like a giant golden starfish, 5 arms radiating out from a single body, each arm holding a row of gates. That shape was not an accident. It was designed by the late British-Iraqi architect Zaha Hadid, specifically so that no passenger ever has to walk more than 2,000 feet from the center to their gate. 2,000 feet is roughly the length of 6 football fields, end-to-end a single straight walk to anywhere in the airport. The terminal covers more than 7.5 million square feet under one continuous roof. To anchor that scale, that is larger than 98 standard American football fields laid side by side. It is the largest single airport terminal ever constructed, and China built it in 5 years. Here is what makes this incredibly exciting. The size is not the headline. The system running inside it is. Beijing Daxing was designed from day one as an artificial intelligence experiment dressed up as a transportation hub. Walk in the front door and a camera identifies you by your face. There is no passport stamp. There is no boarding pass scan. Facial recognition replaces both. Your bag is tagged with an RFID chip that tracks it in real time across every conveyor, every cart, and every loading bay until it lands in the hold of your aircraft. 90% of the touch points a normal passenger crosses on the way to a flight are fully automated, with no human decision required at any point in the chain. If an airport running on facial recognition is already bending your idea of what infrastructure can be, the projects coming up will rewrite it entirely. Hit subscribe and stay with me. Now, here is the layer that puts everything into perspective. The airport handles 100 million passengers a year. To picture that flow, that is roughly the population of Egypt passing through one building every 12 months. And the AI system holding all of that together coordinates aircraft turnaround times, baggage routing, security queues, and gate assignments in real time, with the kind of speed that traditional human-managed airports physically cannot match. The result is a terminal so dense and so efficient that passengers spend less time inside it than at airports half its size. Most countries treat an airport as a transportation building. China treated Beijing Daxing as a prototype for what every piece of public infrastructure could look like when artificial intelligence runs it from the ground up. But applying AI to a single building is only the rehearsal. The next breakthrough is what happens when an entire city is designed by the same kind of system before a single shovel hits the dirt. The city designed before ground was broken. Think about how the city you live in came to be. Think of designing a new city today, like assembling a piece of flat-pack furniture from a complete instruction manual, instead of nailing random pieces together in the dark and hoping the chair stands up at the end. Every part fits the next part. Every wire reaches the right outlet. Nothing has to be torn up later because someone forgot something. That is the principle behind the Xiang'an New Area. 60 miles south of Beijing, on what used to be farmland and small villages, China is building a city from a blank page for 5 million people. To anchor that population, that is roughly the size of metropolitan Sydney, Australia, dropped onto rural Chinese countryside as one coordinated project. And here is what makes the approach completely different. Before construction began, Chinese planners ran the entire urban design through artificial intelligence simulation software. Every traffic flow, every utility line, every emergency response time, every commute pattern. The simulation kept iterating until the layout produced the lowest possible congestion, the cleanest possible air quality, and the shortest possible distance between homes and essential services. Here is the detail that puts everything into perspective. In Zhangjiangkou, all of the utilities, power lines, fiber optic cables, water pipes, sewage, gas run through underground service tunnels rather than across the surface. The streets above are clean. There are no overhead wires. There are no manholes for maintenance crews to dig up. When a cable needs repair, technicians walk through a dedicated tunnel beneath the road. The transit system is coordinated by real-time software that adjusts bus and subway frequency based on actual passenger flow. Any school, hospital, park, or major service is reachable within 15 minutes from any home in the city. And here is the part that almost no Western urban planner wants to admit out loud. The forest coverage of the area, which used to sit at around 11%, has been raised to 35% through deliberate planting before residents even moved in. A city designed to feel like a forest from day one, rather than a forest cleared for a city. Already, more than 100,000 university students and 300 companies have relocated to Zhangjiangkou. To anchor that student number, that is bigger than the total enrollment of every Ivy League university in the United States combined, dropped into a city that did not exist a decade ago. Headquarters of state-owned enterprises are following. Within a decade, this will be one of the largest functioning urban areas in northern China, and it will be the first major city in modern history that was finished on a screen before it was built in the dirt. But planning a perfect city from scratch is still a project that uses tools we recognize. The next breakthrough is a structure so unusual that there is literally nothing else like it on Earth, and it is listening for civilizations beyond our solar system. The eye listening for other civilizations, and the train faster than takeoff. Walk outside on a clear night. Look up at the stars. Now imagine a dish so large that if you placed it on the ground in front of you, it would cover the entire neighborhood you live in. Over 1,600 feet, across the length of about 30 football fields, laid out in a circle, built into the curve of a natural mountain valley in Guizhou province. This dish is not a sculpture. It is a telescope, and it is pointed straight up at the universe, listening for radio signals from things that may or may not exist. It is called FAST, the 500-meter aperture spherical telescope. The name describes the structure. What the name does not describe is what FAST actually does. For decades, the largest radio telescope on Earth was the Arecibo Observatory in Puerto Rico. American astronomers built it in 1963. They used it to discover the first pulsars, to map asteroids, to scan deep space for signs of intelligent life. It was a magnificent instrument and the foundation of half a century of radio astronomy. Then in 2020, Arecibo's cable supports failed, and the entire dish collapsed into the jungle below. The most powerful radio telescope in the Western Hemisphere was gone overnight. Here is the twist nobody at NASA likes to dwell on. China had already built something bigger. FAST switched on in 2016, and it is now the only telescope of its kind operating anywhere on Earth. There is no Western backup, no European equivalent, no Russian counterpart. If you want to point the most sensitive radio ear humanity has ever built at the sky, you point FAST. And since switching on, FAST has discovered over 1,000 new pulsars. 1,000 pulsars is more than every other radio telescope on the planet combined has detected in the same time window. It is also actively scanning for signals from civilizations beyond our solar system. A search humanity has been quietly conducting for decades, now running through Chinese hardware. While FAST is pointed at the sky, another piece of Chinese engineering is screaming across the ground at speeds that defy intuition. It is called the CR-450, a high-speed passenger train. In 2025 test runs, it hit roughly 281 miles per hour on conventional steel rails. To anchor that number, that is faster than a Boeing 737 lifts off the runway during takeoff, a train moving as fast as a commercial jet leaving the ground. Here is the part the wider world rarely confronts head-on. The CR450 is not running on a one-off experimental track. It is built for a network that already covers nearly 30,000 miles of high-speed rail. To picture that scale, that is longer than the entire United States interstate highway system, but designed for trains moving at jet takeoff speeds. And by 2035, the planned network will reach over 43,000 miles, enough track to wrap around the entire planet at the equator nearly twice. But pointing a telescope at the universe and racing a train at jet speed are still individual feats. The final breakthrough is a project nobody has attempted at this scale in over 100 years, and it is reshaping the map of an entire province. The canal nobody has built in a century. The last time the world built a major canal, the year was 1914, and the project was the Panama Canal. After that, the era of cutting through mountains to redirect global shipping went quiet for over 100 years, until China started digging the Pinglu Canal. 83 miles long, carved straight through mountain ranges in southern China in just 3 years, connecting the landlocked province of Guangxi directly to the South China Sea. Cargo ships that used to detour roughly 350 miles around the terrain now take a straight line through it. Here is the truth this entire video has been circling. None of the projects you have just heard about was built because it was easy. None was built in convenient terrain. None was built because the global engineering community agreed it was feasible. Every single one was built because China looked at what everyone else called impossible and treated impossibility as a starting point rather than a conclusion. The era in which the West set the standard for what civilization could build is already over. The new standard is being poured, drilled, and laid, one record at a time. If you found yourself rethinking what your own country is actually capable of by the end of this, the like and subscribe help me keep digging into stories the mainstream press will not touch. And tell me something honest in the comments. Would you rather live in a country that builds like this, fast, ruthless, 10 records at a time, or in one that moves slowly, debates everything in public, and builds half as much? There is no neutral answer. Pick the world you actually want.